Hello everyone, my name is Emmanuel Hassan. Today we are going to talk about the models of the atom. Before we continue with our class of today, we are at the objectives of the studies. At the end of the lesson, students should be able to 1. Define an atom. 2. Explain the particles of atom, that is the electron, proton and neutron. 3. Explain all the atomic models. 4. Explain the limitation of atomic models. So now, let's go to the business of the day. Let's define an atom. We said an atom is the smallest particle of an element that can exist either alone or in combination. An atom cannot be broken by any chemical means. We also say that a typical atom consists of a nucleus of positively charged protons and electrically neutral electrons, with a negatively charged electrons orbiting this nucleus. What we're saying is that an atom is the smallest particle that builds up an element, or is the smallest particle of an element. In other words, we can define an atom as the smallest indivisible particle of an element. What the word indivisible means is that this atom cannot be broken into smaller pieces. We said these atoms consist of what? Of 3 particles. We have the proton, which is positively charged, the neutron, which is neutrally charged, that it has no charge, and the electron, which is negatively charged. We said the proton and the neutron are constituted in a place called what? The nucleus, and this nucleus is located at the center of what? Of an atom. And we said the electron, which is negatively charged, is orbiting what? Round the nucleus. The nucleus happens to be the most heaviest part of what? Of an element. So let's look at a clear diagram of an atom. If you look, the red and the white particles are constituted in a place called what? The nucleus. The red particles that has a plus sign is called what? A proton. The white particle that has no sign on it is called what? A neutron, and it is what? Electrically neutral. It has no charge. While if you look outside the nucleus, we have a green particle that has a sign of minus, and this particle is called what? An electron, and it revolves round the nucleus. Hope you are getting it. Now, so let's look at the various models of what? Of the atoms. We have about 4 models of the atom. So let's look at them one after the other. The first one is the J.J. Thomson's atomic model, or we call it Plum-Pudding model. The second one is the Rutherford atomic model, or planetary model. The third one is the Bohr's atomic model, and the last one is electron cloud model. Now, let's explain these models one after the other, starting with the what? With the J.J. Thomson's model. Thomson held that atoms are uniform spheres of positively charged matter in which electrons are embedded, popularly known as what? Plum-Pudding model. It had to be abandoned in 1911 on both theoretical and experimental grounds in favor of the Rutherford atomic model, in which the electron described orbits about a tiny positive nucleus. What we are saying here is that J.J. Thomson explained an atom to be like a sphere that contains a positive charge particles on it. And within these positively charged particles, a particle is situated within it, which is called the electron. So this is how Thomson explained an atomic structure. If you look at this sphere, the whole red part of this sphere describe the electron, the proton of the element of the atom, sorry. And remember, we said the protons are positively charged particles. If you look at it, within these protons, we have a white particle which has a minus sign, and these particles are embedded in between this proton. The particles are called electrons, and they are negatively charged. So these particles loses its ground because it fails to explain the structure of an atom based on theoretical evidence and experimental grounds. So a scientist now take over called Rutherford, and he named his model Rutherford atomic model. So let's look at what he said. The model described the atom as a tiny, dense, positively charged core called a nucleus, in which nearly all the mass is concentrated, around which the light negative constituent called the electron circulate at some distance, much like planet revolving around the sun. So after the J.J. Thomson models, a scientist called Rutherford bring about a model. He explained an atom as a tiny, dense, positively charged core, and this core that contains a positively charged particle and a neutral particle is called a nucleus. And this nucleus is located at the center of the atom. And according to the Rutherford, he said the nucleus has a mass, or is a place where all the mass of the atom is concentrated on. He further explained that the electron circulate or revolve around the nucleus, just like the way the planets revolve around the sun. So let's look at the diagram. This is how Rutherford explained an atomic structure. If you look at the red and the green particles represent the proton and the neutrons respectively. And a place where these red and green particles are situated is called the nucleus. If you look at it, these blue particles that revolve around this nucleus are called the electrons. This is a perfect model to explain atomic model, but guess what happened? Rutherford model failed to explain the stability of an atom. Remember, we said all atoms are naturally stable. He said the electron revolve around the nucleus. If these electrons are moving around the nucleus, therefore it is said that the electron gains an acceleration. And anybody that is in an acceleration tends to loses its energy. Therefore, according to the Rutherford atomic model, this electron as it is revolving around the nucleus, it is losing its energy. And when it is radiating out its energy, there is a tendency that when it loses the whole of its energy, the electron will fall into the nucleus. And when this electron falls into this nucleus, it is said that the atom will collapse. And when this atom collapses, it is said that the atom is unstable. After so much struggle, a scientist called out with an experiment, and this called Niels Bohr. Niels Bohr named his model Bohr's atomic model, and this is what he said. He have two postulates. The first postulate says only certain special orbits called discrete orbits of electrons are allowed inside an atom. That is, the first thing he did is that he discovered what a discrete orbit, or we call them what energy levels, or in another word we call them shells. The second postulate says that while revolving in this discrete orbit, the electrons do not radiate energy. That is, since these electrons are situated on this orbit, as it is revolving around the nucleus, they did not radiate their energy. They will not lose their energy. He said the shells are named as the K shell, L shell, M shell, and N shell, starting from the smaller shell that is closer to the nucleus. And we can also number this shell as N equals to 1, N equals to 2, N equals to 3, and N equals to the 4, starting also from the nucleus, the shell closer to the nucleus. And for us to get the maximum number of electrons in an orbit, we use this formula, which is 2 times n raised to the power of 2, where n, the small letter n, stands for the numbers of shell. Let's look at the diagram. This is how Bohr explained his atomic structure. If you look at it, the shell closer to the nucleus is numbered n equals to 1, the one following it is numbered n equals to 2, and the third one is numbered n equals to 3. The electron revolves round the nucleus in an orbit. And since these electrons are revolving around this nucleus in an orbit, these electrons do not lose its energy. The only thing that happens is that when the electron gains energy, it's jump from a lower energy level to a higher energy level. And when it loses its energy, it goes back to its original shell or energy level. This is how it is explained. If you look at it, from n equals to 2, when it is excited and when it gains more energy, it jumps to n equals to 3, which is the third shell. And when it loses its energy, it goes back to its original shell, which is n equals to 2. So now, the last one is electron cloud model. Let's look at what this model says. The model is used to describe the probable locations of electrons around the atomic nucleus. The electron cloud is also defined as a region where an electron forms a three-dimensional standing wave, the one that does not move relative to the atomic nucleus. The model does not depict electron as particle moving around the nucleus in a fixed orbit. Based on quantum mechanics, it gives the probable location of electrons represented by electron cloud. What this model is saying, or what this model is talking about, is saying that the electron cloud model is used to identify the possible location of an electron in an atom, or to identify the exact location of an electron in an atom. According to Niels Bohr, he explained an atom, an electron, to be a particle that revolves around the nucleus, just like the way the planets are revolving around the sun. But the electron cloud model does not explain the electrons like that. They said the electron forms a cloud outside the nucleus. And we use the electron cloud model to identify the possible locations of this electron. Let's look at the diagram. This is how it looks. The red dot at the center here, it signifies the atomic nucleus, while the little black dots around signifies the probable location of the electrons in that atom. Let's continue. We have some physical limitations of this model. Let's look at them one after the other. We said it violates the Heisenberg uncertainty principle. The Bohr atomic theory considers electrons to have both known radius and orbit, that is, known position and momentum at the same time, which is impossible according to Heisenberg. If you could remember, Heisenberg talks about the duality of nature of matter. That is, a matter can behave as a wave and as a particle, but not simultaneously. But Bohr says an electron but Bohr determine the position and momentum of an electron at the same time, which according to Heisenberg, it is not possible. The second one is the Bohr atomic theory made correct prediction for smaller size atom like hydrogen, but poor spectral predictions are obtained when larger atoms are considered. Bohr uses a hydrogen atom to explain his model, and he got the answer correctly. But when he tries to use larger atoms like carbon, oxygen, he finds it difficult to obtain a result, a accurate result, because the elements are larger than the hydrogen atom. Then the third one, it fails to explain Zeeman effect. And Zeeman effect means that when the spectral line is split into several components in the presence of magnetic field. It also fails to explain what Stark effect, and Stark effect is the process whereby a spectral line gets split up into fine lines in the presence of electric field. Then the last one is the Plumpudding model lacked experimental evidence, and hence Rutherford conducted many experiments in order to determine the structure of an atom. So now let's go to the summary of what we discussed today. The first one is that we define an atom. We said an atom is the smallest particle of an element that can exist either alone or in combination. An atom cannot be broken by any chemical means. We also talk about the four models of the atom. We said the Rutherford model described the atom as a tiny, dense, positively charged core called a nucleus, in which nearly all the mass is concentrated, around which the light negative constituent called the electron revolves around the nucleus. The Thomson held that atoms are uniformly sphere of positively charged matters in which electrons are embedded. The Bohr model discovered the energy levels, which is the same thing as shells, and explained the stability of electron. The electron cloud model provides the means of visualizing the position of electrons in an atom. We also explained the limitations of the physical model. We said the first one, it violates Heisenberg uncertainty principle. The second one, it fails to explain Stark and Zeeman's effect. The third one, the Thomson models lack experimental and theoretical evidence to explain atomic structure. Now, assignment. Students should perform this assignment. Number 1, define an atom. Number 2, identify the particles that made up an atom. Number 3, using suitable diagrams, explain the 4 atomic models. Number 4, explain 3 limitations of physical model. Thank you. Please, if you enjoyed this video, go to our YouTube channel and subscribe. See you in our next class. Bye bye.